Yeah, hi, this is Rohit. I'm DB2 consultant and I'm having 6 years of experience in DB2 databases. Primarily, I'm working in DB2 Linux, Unix, and Windows platform. So here today, I'm going to present DB2 database. And in this session, basically, I will focus on DB2 fundamentals. So let's start with this. This is basically a typical web application architecture. You can see that there are application servers and web servers, and you can see that there is a database server. So this demonstrates how typically an application server connects to the database server, and this is you can see the browser. So it's basically a typical web architecture for a typical database application. So if we see the DB2 tools and products, the IBM provides a variety of tools, database tools and products in different areas. If we talk about DB2 Control Center, then you get DB2 Web Query Tool, DB2 Recovery Expert, DB2 HPU, that is for the high performance unload, DB2 Performance Expert. So these tools comes according to the variety of operating system. If you have Windows operating system, then you have Control Center, and also you have DB2 Visual Explain. So we'll look these tools, but for now I'll focus on DB2 fundamentals. So let's start with the very basics of the DB2, that is the instance and database. As you can see here, instance basically an environment. Instance inside the DB2 provides an environment for the database to be hosted. So first of all, if you talk about database, so let's talk about instance first, because unless you have an instance, you won't have a database. So if you can see here that I have 3 instances in this box. Basically, let's assume this is a server, and in a single server, I can have multiple instances. So this is the instance 1, this is the instance 2, and this is the instance 3. So each instance can have multiple databases. So, and every instance has its instance configuration file. That we say the database manager configuration. So the configuration that you apply for the instance 1, those configuration will apply to the all database that resides in instance 1. And whatever the instance configuration you apply for the instance 2 will only apply to the databases that is residing in instance 2. So basically the databases in instance 1 is segregated from the databases in instance 2. The DB2 registry variables are another concept. Basically it applies to the operating system level. So when you set a DB2 registry parameter, that parameter affects all the instances within a server. So let's say if you set the DB2 communication protocol, that is one of the DB2 registry variable, if you set it to TCP IP, then all DB2 instance will use the same protocol, that is the TCP IP. That will apply for each and every instance inside the server. And now, and when you if you see the database, then the database has different objects. Inside the database, you have table spaces, you have triggers, you have views, you have stored procedures, constraints, and every database has its unique database configuration file. So let's say if instance 1 has 2 databases, database A and database B, then both database will have its own database configuration file. So changes to any of the database configuration file will not affect other. So from this diagram, you can see the instance 1 has 2 databases. One is the database 1 and another is database 2. And each database has its own set of objects. So let's see that instance and database, as I've covered in the demonstration, DB2 instance is simply called a database manager because it manages the databases. And it can access more than one database at a time. As I told that an instance can have multiple databases with different names. Okay. So this is a typical database server where you can have multiple instances. It's just a demonstration, as I explained earlier, that this database server has two instances, an instance 1 having two databases, database 1 and database 2, an instance 2 having another database, that is database 3 and database 4, and this is the admin server. So the admin server basically manages the instances within a server. Okay, this is basically a typical DB2 process model. I won't go in much detail about DB2 process model. At this time, basically I'm focusing on DB2 fundamentals. So let's move to this topic sometime after, but first I'll focus on DB2 fundamentals. Okay, so let's talk about the DB2 memory model. Basically, DB2 memory is divided into it's basically divided into mainly three parts. One memory is one memory is basically is the instance shared memory. Another set of memory is the database shared memory, and the third memory type is application heap. So let's say that the instance shared memory is required for the instance management, because in every database server box you have instance. So for managing the instance you need some memory, and also there are some instance specific configuration parameters like monitor heap size, audit buffer size, and FCM num buffers. So these memory elements are required to be managed by instance. So they need some memory. So that will be instance memory. Another type of memory is the database shared memory. So if you can see in a database, we have buffer pools. So the buffer pools is like a memory area where all the database and all the database pages, all the recent database pages will be kept. When you execute a selector statement, then it fetches data from the disk and put this data into the main buffer pools, and then the application view the data. So basically, the most of the database memory is occupied the buffer pool. So let's see if you have 50 GB reserved for your server, then mainly 75 to 80% is reserved for database buffer pools. And then you have another database memory parameters like lock list, catalog cache, package cache, and the sort heap. And the some memory is reserved for the some memory is reserved for the lock list, because when the DB2 locks a particular row, it needs some memory. So that is memory is consumed by lock list parameter, and obviously if you want your data to be sorted, then definitely the DB2 engine tries to sort the data. For that purpose, it needs sort heap threshold, so, and also the utility heap size. One second. So, and the third type of memory is the application group shared memory. So basically, this memory is related to the application agent. So let's say that query that checks the status of your file. It can be anything specific to your application. So what DB2 does when it sees an incoming connection request requiring selecting a data from a particular table, then it assigns an agent to that connection. So on behalf of that connection, the agent starts working for that query. Okay, you need to select data from this particular table. Okay, the agent is here. I'm here for you to serve on behalf of that connection. So that some amount of memory will be allocated to the agent. So it can select the data from the table, and it can put the data temporary in the agent heap and return it to the application. So that is where the application group shared memory comes into the picture. And now, when you look broadly at the database manager shared memory, then you will see three types of memory are there. Three types of memory sets are there. One is the database system monitor heap, that is the monitor heap size. The monitor heap size is required when you want to monitor databases within the instance. So let's say you want to monitor the databases. You want to look at the performance attributes. You want to look what all costly queries are running inside my database. So before you can monitor your database, you need to provide some monitor heap. You need to provide some memory to this parameter, and this parameter is configurable online. That means you do not need to bring your database down. You just update this parameter and the DB2 will allocate the memory as required. The next memory requirement is audit buffer size. Definitely today in the growing database environment, everyone wants the database to be audited, because for some reason that that someone unauthorized person should not access to the database. So somewhere such kind of reporting should be logged. So that is where the audit is required. But before that, you need to enable the audit, and you need to provide some memory to the audit buffer size. And the third one is the fast communication manager. That is basically when you have multi-partition databases, then you have fast communication manager enabled, and you will provide some amount of memory to the FCM. And then comes to the database memory. So in the database memory, as I explained you earlier, there are buffer pools, and there is log buffer size, catalog cache, and the restore buffer, package cache, the log list. So these are basically the building memory blocks of a database. Okay, and now here comes the agent private memory. As I explained you earlier that when an incoming DB2 sees incoming connection request, then it allocates a memory to the agent, so the agent can work on behalf of that connection. So on agent part, it has its own sort heap, the Java heap. So basically, these all are very internal DB2 memory structure. Okay, and now we'll focus on the storage model, because that is very much required when you try to understand DB2. Basically, a page, the DB2 data concept is actually works on the concept of an OS page. So generally, the OS manages the page of size 4 KB, 8 KB, 16 KB, and 32 KB. And that the same concept is used by the DB2. So if you can see this, this is a page. So basically this page can be of 4K, 8K, 16K, or 32K. That means a page can hold data up to the 4 KB or 8 KB or 16 KB or 32 KB based on the design you have chosen. And now this is the extent. So when you put all the OS pages continuously, so let's say I put 4 pages continuously. So in DB2 terms, we'll say it extent. So I'll explain you that how the page and extent concept is used in DB2. But for now, you can see the page is a single unit, and extent is if you combine multiple pages, then you will call it as extent. And now If you see this, then you will understand that this is the storage structure hierarchy. So here, the OS page directly correlates into the DB2 page. And if you club multiple DB2 pages, then it will become an extent. And in these extents, you can put your database objects. And the database object always resides in a table space. So here you see is completely the logical concept, and here you see is the physical concept. So basically these all are logical things, and this is actually the physical things. So your data is ultimately placed in containers. One second.